Hi everyone. Today we're going to study minimum spanning tree. Let us define first weighted graph. A weighted graph is a graph for which each edge has an associated real number weight. The sum of the weights of all the edges is the total weight of the graph. Example, the figure shows a weighted graph. This is our graph. Each edge has a weight. For the total weight, we're going to add all the weights. So we have this 2 plus 6 plus 3 plus 2 plus 3 plus 1 equals 17. Now let's go to minimum spanning tree. For illustration, we have like this. A company plans to build a communications network connecting its 5 computer centers. Any pair of these centers can be linked with a leased telephone line. Which links should be made to ensure that there is a path between any two computer centers so that the total cost of the network is minimized? We can model this problem using weighted graph, where vertices represent computer centers, edges represent possible leased lines, and the weights on edges are the monthly lease rates of the lines represented by the edges. This problem can be illustrated by this figure. We can solve this problem by finding a spanning tree so that the sum of the weights of the edges of the tree is minimized. Such a spanning tree is called a minimum spanning tree. Let's define minimum spanning tree. A minimum spanning tree in a connected weighted graph is a spanning tree that has the smallest possible sum of weights of its edges. If capital G is a weighted graph and E is an edge of G, then W of E denotes the weight of E, and W of G denotes the total weight of G. Example, find the three spanning trees of the weighted graph below. Also, indicate the minimal spanning tree. This is our graph. We can see that there are 6 vertices and 6 edges. For this graph to be a tree, there must be 6 vertices and 5 edges. So, we're going to delete one edge. In deleting an edge, we will delete an edge in the cycle in the graph. The cycle is somewhere here. We're going to delete one edge in the cycle alternately. This is now the first graph. In here, we remove the edge with weight 3. And then the W of t sub 1, or the weight of this graph, equals 14. Next is when we delete with weight 6. So the graph becomes like this. This is our t sub 2. And the weight of t sub 2 equals 11. Next, in the graph, we're going to delete this edge with weight 2. And the graph becomes like this. This is now our t sub 3. The weight of t sub 3 equals 15. From this spanning trees, we can see that t sub 2 is the minimal or minimum spanning tree, since it has the minimum weight among the spanning trees. We can see that the weight of t sub 2 is 11, which is the least.